Hey, welcome back. This is the video for U2A6, which covers word problems or real-life applications of algebra. The challenge here is not in doing the math. There's no new math in this lesson. We're going to use the distributive law. We're going to collect like terms. We're going to solve equations, things that we've been doing for this entire unit. The challenge is often in translating the English to the math. So I think of math as a language, just like English or anything else. And so every time we do a word problem, at the start, we have to translate the English to math. Then we solve the math, which is the part that's usually the easiest. And at the end, we need to translate the math back into English to answer the question. So the first two examples we're just going to practice writing these sentences as equations. So each word or each phrase in this sentence, we can translate to a number or a symbol. So whenever we see is or is the same as or is equal to, that we can represent that with an equal sign. So is always where I should put the equal sign. The right side of the equation is pretty easy. It's just 17. So we have 3 more than a number is 17. 3 more would mean plus 3. And a number we could represent with any variable. So a number is something we don't know. So I could write x plus 3 equals 17. So that means 3 more than a number is 17. You could also write it as 3 plus x equals 17. Addition is what we call commutative, so it doesn't matter which order I write the two terms. So these are both of the same solution. I think you probably know that the answer would be x equals 14. Let's try another one. This is slightly harder. Again, I like to look for the is or the is equal to first. So 5 less than a number is twice that same number. So again, let's let x represent our number. 5 less than a number would be 5 less than x. So x take away 5. That's 5 less than x is twice the same number. Any word like twice or thrice or 4 times means we multiply. So I want to multiply the same number by 2. That's what twice means. And the way we write multiplication, if I want to write 2 times x, well, that's the same as writing 2x. So there I've translated this sentence into an algebraic equation. I want to go slowly. I want to look for my is. If I see something like a number or the cost or something I don't know, I can represent that with a variable. One thing to be careful about is x minus 5 is not the same as 5 minus x. So those are not the same. Subtraction is not commutative. You can think about if x was 10, then 10 minus 5 is 5. But 5 minus 10 is negative 5. So they're not the same thing. So be really careful reading the sentence. It wants us to do 5 less than a number. So that's x take away 5. So that's how we translate a sentence into an equation. Let's actually now apply this to solve a few word problems. So our first example is we have 3 consecutive odd numbers that have a sum of 159, and we want to know what are those 3 numbers. So the first thing we always want to do is we always want to define our variable. So in this case, I'm going to let x represent the smallest of the 3 numbers. So we always want to write a let statement to help us say, what variable am I going to use and what is it going to represent? So x is going to represent the smallest of the 3 numbers. All of the questions that we do in this unit, we're going to use one variable and one equation. So x is going to represent the smallest of the 3 numbers. So let's start our equation with x. Now, they have a sum, so I'm going to be adding. So I need to add the smallest number, then the next smallest number. So consecutive means in a row, and odd numbers are always 2 apart. Think of 3, 5, 7, 9. So if x is my smallest number, my next number would be x plus 2. It's got to be 2 bigger. And then the next one would have to be x plus 4. So just think about it. If x was 11, then my next number would be 11 plus 2, 13, and the next would be 15. Altogether, they equals 159. So this is often the most challenging part, is changing my sentence into an equation. And now I'm just going to, first I can get rid of the brackets, so they're just all being multiplied by 1. So if you want to skip this step, that's okay. Then I'm going to collect like terms. I have x plus x plus x, so I've got 3x. I have 2 plus 4 equals 6 equals 159. When I bring the positive 6 to the other side, I need to subtract it. So now I have 3x equals 153. To get rid of the times 3, I have to divide on the other side. 153 divided by 3. So x equals 51. So now I've solved the math equation. I'm still not done. Now I need to write a concluding sentence. Well, what have I learned? Well, the smallest number, that's what x represented. The smallest number is 51. And therefore, the 3 consecutive odd integers, so I'll just say the 3 numbers, are 51, 53, and 55. And the nice thing about word problems is often really easy to check your answers. Does that fit what the question asked? Well, I've got 3 consecutive odd numbers, and do they add up to 159? They do, so I've solved my problem. So each problem you solve should have this same general format. I should have a let statement defining my variable. I should have an equation that uses that one variable. I should solve the equation and then write a therefore statement. So we start by translating English to math. Then we solve math, and then I translate my math back into English. Let's just do a couple more examples. This one is about a litter of puppies. The runt of the litter weighs 5 pounds less than each of the other dogs, and combined they weigh 37 pounds. So I'm going to want to start with an x let statement. So I'm going to let x represent, and you don't need to use x. Sometimes a different letter might make sense in the context of a question. So if you're dealing with cost, you might want to use C. If you're dealing with height, you might want to use H, and length L, but X is a pretty good letter to use. Let X represent, I've got 3 puppies, and it talks about the runt of the litter first. So we'll say let X represent the weight of the runt. So the runt is the smallest dog in a litter. And we should always kind of include our units. So we want to represent the weight of the runt in pounds. So the runt of the litter, X, weighed 5 pounds less than each of the other dogs. So there are 2 other dogs, and each of them is going to be 5 pounds more or 5 pounds heavier than the runt, because the runt weighed 5 pounds less. So I have X plus 2 times X plus 5. This bracket is the weight of the other dogs. And all together, again, it's a sum problem. When I add those all together, it's a combined weight of 37. So again, when I'm solving an equation, I don't want to have any brackets, so I want to expand. So I have X plus 2X plus 10 equals 37. Then I can collect my like terms. I have 3x plus 10 equals 37. So 3x equals 27. And then my last step is just to divide by 3. So x equals 9. What was x? X was the weight of the runt in pounds. So the runt must weigh 9 pounds. And the other 2 dogs were 5 pounds heavier. So I can say, therefore, the 3 dogs weighed 9 pounds. We use LBS to represent pounds. 14 pounds, and another dog of 14 pounds. So I've got a concluding statement that sums up what I knew, and I have my units, and I have a full sentence as well. It's kind of a messy way to write pounds, but I'm saying the dogs are 9, 14, and 14. So again, the key part is choosing what do we want x to represent, then setting up an equation in only one variable, solving that equation, and then interpreting it. Let's do one more. Joe goes to the gym. A lot of gyms work like that. You got to pay and a lot of country clubs like golf clubs, tennis clubs work the same way. If you go to the gym, you got to pay a one-time initiation fee. So you just pay that once at the start of $65. And every month he's got to pay another $13. I made up these numbers, but that's a really cheap gym. And so far he's paid $143. How long has he been a member? I forgot my question mark. So we want to know how many months Joe has been going to the gym. Oftentimes, the question at the end of a word problem will kind of tell us we want to know how many months Joe's been a member. So why don't we let M represent the number of months. So I'm using M to stand for months, and often what the question is asking for can help us choose a variable. So you've got to pay a one-time initiation fee of $65, and then every month you pay 13 more. So if you've been going to the gym 10 months, you would have paid 10 times 13 or 130. So for every month, you pay 13, so we can do 13 times M, and that will be the total of his monthly fees. So the initiation plus the total of his monthly fees will equal the total amount that Joe has paid so far. Okay, so we can solve this equation. I want to isolate for M. So first I'm going to move the plus 65 onto the other side, so it becomes the opposite, or a subtract 65. So I have 13M equals 78. I've got 13 times M, so to move the 13 to the other side, I need to divide my right-hand side by 13, so M equals 6. So again, I've defined my variable, I've translated my English into math, I've solved the math, and so my last step is to write a therefore statement. These 3 dots mean therefore. Joe has been a member for 6 months. So I think the best advice I have for word problems is to do a lot of practice problems. You'll see patterns and types of problems that come up again and again and again. The challenging part, I don't know why I have a question mark there, is defining the variable and creating the equation. I'm pretty confident that we're all, by now, experts at solving the equation. So just make sure you kind of follow that rough format, do lots of practice, and of course, send me an email if you have any questions. Okay, bye for now.